What if the people you were taught had vanished from history, are still inside you, not just metaphorically, but biologically? Forget everything you thought you knew about the origins of the Lebanese people. Because in 2017, scientists did something no historian could ever do. They exhumed the past not from ruins or scrolls, but from 5 ancient skeletons, buried deep beneath the soil of Sidon, one of the oldest continually inhabited cities in the world. These weren't just any bones. They were 4,000-year-old Canaanites, a civilization long dismissed by textbooks as extinct, absorbed, erased, forgotten. But when their DNA was sequenced and compared to the genomes of 99 modern Lebanese individuals, something stunning emerged. The result: over 93% of modern Lebanese autosomal DNA is genetically identical to these ancient Canaanites. That's not a resemblance. That's not coincidence. That is continuity. For nearly 3,700 years, despite Roman occupation, despite Islamic conquest, despite the arrival of the Ottomans, Crusaders, and the French Mandate, the core of Lebanese DNA has barely shifted. Empires came and went, but the blood stayed. But the story goes even deeper, because the Canaanites were not a pure race. They were already a hybrid people, formed by a genetic fusion. Neolithic Levantine farmers who settled these lands over 10,000 years ago, and Eastern migrants, possibly from the Iranian plateau, who arrived around 5,000 years ago. This mix laid the genetic foundation of modern Lebanon, a foundation so resilient it absorbed thousands of years of invasions without being erased. Imagine it: cities burning, dynasties falling, temples crumbling, yet something invisible, something sacred survived. And that something is you. So when you walk the streets of Beirut or Byblos or Tyre, you're not just standing on history, you're carrying it in your cells, in your bones. But here's where the mystery begins. Amidst this unbroken Levantine genome, scientists discovered a code that doesn't belong, a strand of DNA, not Middle Eastern, but unmistakably Western European. And it appears, almost exclusively, in one Lebanese community. So who were these foreign ancestors? And how did their bloodline survive, hidden for nearly 900 years? A medieval army marched through Lebanon with swords and crosses, but what they left behind was inside your genes. It was never written on a stone tablet or carved into castle walls, but it's there, in the blood. Around the year 1099, waves of heavily armed Christian knights poured into the Levant. They came from France, England, Germany, riding under papal banners in what became known as the First Crusade. They built fortresses on the coast, waged holy war inland, and carved out Latin states: the county of Tripoli, the Principality of Sidon, and the Kingdom of Jerusalem. But while history focused on their battles, DNA remembered something else. In 2008, a study led by Pierre Zaloa revealed a genetic ripple still present in modern Lebanese Christians. The Y chromosome haplogroup R1b, the most dominant paternal lineage in Western Europe. Not a trace from nearby Armenia or the Mediterranean, but one exclusive to the British Isles, France, and Iberia. Even more stunning, this R1b subtype is almost completely absent east of Hungary, except in Christian Lebanese males. It does not appear significantly in Muslims. It's rare among Druze, and yet it persists, like an echo, a signature left by Crusader fathers. These weren't isolated cases. The distribution pattern matched the exact historical geography of Crusader settlements. It was like a genetic map, tracing lineage, not loyalty. This wasn't coincidence, it wasn't myth. It was a direct biological imprint from the 11th to 13th century, when Western European men, warriors, pilgrims, settlers, arrived in small numbers but made permanent genetic impact. Historians remember the walls of Beaufort Castle or the sea fortress in Sidon. But DNA remembers something far more intimate. Not conquest, but conception. The Y-DNA doesn't lie, because even when the Crusaders were later expelled by Mamluk forces in 1291, their sons stayed. But to truly understand how deep this invasion went, and how real the legacy became, we have to go back to the very soil of Sidon. Because inside the bones of actual Crusaders, something else was found. The true shock wasn't in percentages, it was in the skeletons, knights buried beneath Sidon, and the mixed children they left behind. In 2019, archaeologists uncovered a medieval mass grave in Sidon, but what they found wasn't just bones, it was biological proof that rewrites history. Beneath the coastal streets of Sidon, where Crusader stone once met Phoenician ruins, a silent pit waited to be unearthed. Dug sometime around 1250 CE, during the final bloody years of Crusader rule, it held the remains of at least 25 individuals, hastily buried, some still wearing fragments of armour. But it wasn't the burial that shocked scientists. It was the DNA inside the bones. Out of the 9 skeletons tested, a pattern emerged like something from a cinematic script. 3 belonged unmistakably to Western Europeans, likely knights or soldiers from France, Italy, even as far as England. 4 were fully local Levantines. And then came the twist. 2 skeletons were hybrids, admixed, as the genetics term it. One of them, labelled SY41, was perhaps the most unexpected of all. His Y-DNA revealed haplogroup R 1b-DF27, a subclade found most commonly today in northern Spain and southern France, nowhere near the Levant. But his mtDNA, passed down from his mother, belonged to haplogroup HV0, which traces back to ancient maternal lineages native to the European Mediterranean. This was no simple intermingling of soldiers and villagers. This was genetic intimacy. A literal child of 2 worlds. Crusader father, local or possibly even European Levantine mother. It wasn't just a grave, it was a time capsule, cracked open, exposing proof that Crusaders didn't just invade. They integrated, at least briefly. They created life. But if children were born, if bloodlines crossed, why don't we see them now? Where did these mixed lineages go? Why did this visible, testable European ancestry evaporate? If Crusaders left sons in the Levant, why has their DNA all but disappeared from modern Lebanese genomes? A warrior's child was born in Lebanon, yet within generations their lineage dissolved into silence. He was real, his body buried in Sidon, sword fragments near his ribs, but his legacy erased by time. The Crusaders came in waves, 1099, 1148, 1190, carving fortresses across the Levant. They fought, they built, they fathered children. And yet, despite leaving behind genetic breadcrumbs like Y chromosome haplogroup R1b, something strange happened. Their wider DNA footprint vanished. In 2019, a team led by Mark Haber, using advanced genome-wide analysis, studied those same Crusader-era remains from Sidon. Their discovery, the autosomal DNA, the full ancestral makeup of those Western Europeans, left no detectable mark in the modern Lebanese population. None. Gone. How? The answer lies in both history and biology. By 1291 CE, the Mamluks had driven the last Crusader strongholds into the sea. the Latin states collapsed. Crusader settlements, from Tripoli to Acre, were burned, evacuated or slaughtered. The Crusader elite was gone, but more importantly, they had never truly blended in. These weren't mass settlers, they were mostly isolated military males, few families, few wives, few true unions. Those that did occur, as seen in Sidon, were rare. And in a population of hundreds of thousands, even thousands of Crusader offspring over time become just whispers. Think of it like a drop of crimson ink in a deep, ancient sea of Canaanite blue. Statistically, a modern Lebanese Christian man might still carry R1b, that European Y DNA, yet 95% of his genome is still native to the Levant. That lone Western signal, passed only father to son, cannot outshout the chorus of local blood. The Crusader's child existed. But the genome forgot. His DNA was diluted over centuries, not erased but absorbed, hidden behind stronger, older foundations. And yet, what if Crusader genes weren't the first European strands to enter Lebanon? What if some of those foreign signals, those Western echoes, came long before the Crusades ever began? But what if some European genes arrived far earlier, long before a Crusader ever set foot here? Europe didn't just send genes to Lebanon, it received them 10,000 years ago. Long before Rome, before Greece, even before Hapaim, the pharaohs of Egypt, there was a wave. But this one didn't come crashing into Lebanon, it left it. Roughly 10,000 years ago, as the last ice age faded, humans in the Fertile Crescent, stretching across modern-day Lebanon, Syria, Iraq and southern Turkey, discovered something that would transform the world: farming. And with farming came something else: migration. They were Neolithic pioneers, the first to sow wheat, herd animals, ferment grapes, build permanent homes. And around 8,000 to 6,000 BCE, some of these early Levantine farmers began pushing westward, across Anatolia into the Balkans and eventually deep into Europe. Their genetic trail is written in haplogroup J2, still dominant in Lebanon today, but also common in southern Italy, Greece, the Balkans and parts of Spain. This wasn't a conquest, it was a civilizational gift. They brought not just seeds, but the foundations of European agriculture. They carried language roots that would one day branch into Indo-European tongues. And they planted the DNA that now runs through the veins of millions of southern Europeans. That's the reversal. We often talk about European genes reaching Lebanon through crusades, colonization, empires. But what if it started the other way around? What if ancient Lebanese blood helped build Europe? From stone temple designs found in Malta to the spread of olive oil and wine, the cultural echoes of this migration still shape the Mediterranean world today. So when a modern Greek man or southern Italian carries J2 DNA, he may unknowingly be tied to a man who once farmed barley in the Bikaya Valley. The direction of influence wasn't always west to east. Sometimes it flowed the other way. But this entire story has focused on fathers. Y chromosomes, patrilines, and yet mothers leave traces too. But what about the maternal line? Could it carry stories that the paternal markers missed? One Phoenician woman, buried in Carthage, carried the whisper of Iberia in her bones. We followed the trail of fathers, from Bronze Age chieftains to Crusader knights. But now the focus shifts to the other half of every lineage. Mothers. Mitochondrial DNA, or mtDNA, is passed from a mother to all her children, unchanged, generation after generation. And in 2014, a genetic discovery changed everything we thought we knew about ancient Mediterranean women. inside a 2,500-year-old tomb in Carthage, Tunisia. Archaeologists unearthed a skeleton known as the Young Man of Byrsa. His bones belonged to a male, but his empty DNA told his mother's story, and it didn't point to Africa or the Levant. It pointed west to Iberia. His mitochondrial haplogroup was U5B2C1, an extremely rare lineage found most often in Portugal and northern Spain, and almost unheard of in the ancient Near East. Which means one thing: a woman, likely of Iberian origin, was once part of the Phoenician network, and her child ended up buried not in Europe but in North Africa. It's not a fantasy, it's math and molecules. This wasn't an isolated case. The Phoenicians, masters of maritime trade, connected Sidon, Tyre and Byblos to distant ports like Gadir, modern Cadiz. Their ships carried goods and people, marriages, relationships, children, all left invisible signatures behind. So while European maternal haplogroups do appear in the Levant, they never dominate. They are traces, not tides, and that's where things get complicated. Because in today's world of DNA tests, a single European haplogroup can be misread as a complete identity. But that's not how history works. Yet even now, people misread these traces and mistake ancestry for identity. A Lebanese man tests his DNA. It says Western European, but 93% of his genome tells a different story. It starts with a test, a sleek home kit, a cheek swab, and suddenly identity is redefined. He uploads his raw data. The report comes back: Y chromosome haplogroup R1b, the most dominant male lineage in Western Europe, France, Spain, Ireland, England. But here's the catch: Y DNA is just one thread. It travels down a single line from father to son, ignoring every mother, every other ancestor, every layer of complexity. His autosomal DNA, the full genome, the total inheritance from all sides, comes back as over 90% Levantine, Canaanite, Phoenician, Arab, native. But what does he tell his friends? I'm European. This is the trap. One genetic marker gets inflated into a cultural identity, a psychological truth built on a biological fraction. In 2008, Pierre Zaloua's study revealed that R1b is far more common among Lebanese Christians than Druze or Muslims, igniting speculation. But the rest of their genomes, still overwhelmingly Eastern Mediterranean. The myth spread. The narrative took hold. Gene equals identity. 1% equals everything. And yet, genetics doesn't work that way. Imagine standing in a crowd of 512 of your ancestors, going back just 9 generations. That one man who passed down 1 billion rand, he's just one face in the sea. 511 others came from somewhere else. Still, the story sticks. Because it feels powerful. It separates, it elevates, it answers old questions with new science, simplified for the soul. But in Lebanon, this wasn't just personal. This illusion, this mistake, became a national myth. And in Lebanon, this misreading gave rise to a national myth with powerful political implications. What happens when science is used to divide instead of unite? In the early 2000s, a new wave of identity surged in parts of Lebanon's Christian Maronite community. It wasn't Arab, it wasn't Islamic, it was something older. Or at least, that's how it was sold. Phoenicianism. The idea that modern Lebanese Christians were not Arabs at all, but direct descendants of the ancient Phoenicians, seafaring traders who once ruled the Mediterranean from 1000 to 300 BCE. This wasn't just cultural nostalgia, it became political. It shaped flags, schoolbooks, slogans. And when DNA entered the conversation, it was claimed as proof. Studies like Zalua's 2008 research did confirm something remarkable: strong genetic continuity from Bronze Age Canaanites into modern Lebanese people. But here's the twist. That continuity didn't only exist among Christians, it was just as strong in Muslims, Druze, even Samaritans. Phoenician blood, if you want to call it that, wasn't the property of any one sect. It was Lebanon's collective inheritance. But the story was bent. A single Y chromosome marker, a historical thread, a misinterpreted migration, all spun into the idea of genetic purity, of ancestral ownership. And that's where science, twisted by politics, became dangerous. Because DNA doesn't care about religion, or flags, or borders. It remembers migrations, marriages, survival. And yet, it's so easy to weaponize. In a country fractured by civil war, sectarian politics, and centuries of foreign intervention, this kind of genetic nationalism offered something seductive: simplicity. But simplicity is the enemy of truth. And the truth, it's more complex and more beautiful. Because buried beneath the labels, DNA carries a different kind of marker, one carved not by tribe, but by faith. But there's one thing even politics couldn't erase: the religious fingerprint in Lebanese DNA. In Lebanon, your religion could tell more about your DNA than your surname. Here, identity isn't just etched in faith, it's etched in chromosomes. Lebanon's tapestry is older than its borders, stretched across centuries of conquest and coexistence. But when Pierre Zalua and Mark Haber published breakthrough genetic studies, they revealed an extraordinary truth. Religious affiliation, more than geography, aligned tightly with genetic structure. While two nearby towns may share street names, a Maronite Christian from one town often differs genetically from a Muslim in the other. The evidence appears in haplogroups. For many Lebanese Christians, particularly in Mount Lebanon, there's a lingering echo of Crusader-era paternal DNA R1b. In contrast, among many Muslim communities, a different paternal signature emerges, haplogroup J1, rooted in ancient Arabian gene pools. And then there are the Druze. Their genetic isolation over centuries created a distinct DNA profile all their own, sparse outside mixing, generations of endogamy, of faith-bound marriage, buried ancient migrations inside each community. It's breathtaking when you think of it. Centuries of wedding traditions, of marrying within the fold, built invisible genetic fortresses. DNA became memory. DNA became identity, not just through language or ritual, but through minute changes in mitochondrial markers, in Y chromosomes, passed again and again within dominions of faith. And yet, deep within this faith-shaped genome lies a lesser-known beat, one that traces beyond the sands of Arabia and far past the airs of Crusader castles. A signal older and stranger, pointing far beyond Rome, beyond Arabia, beyond anything we've discussed so far. But there's another genetic pulse inside Lebanese DNA, from a place far beyond Rome or Arabia. 3,000 years ago, steep warriors swept across Asia. You still carry their dust in your cells. That whisper beneath your skin wasn't always Levantine. It came from the endless grasslands of the Eurasian steppe, a world away, yet written into your DNA. Modern genomic studies reveal something staggering. Approximately 7% of Lebanese ancestry derives from Bronze Age steppe populations. Nomadic hunter-gatherers and early Indo-Europeans who roamed from the Carpathians to the Altai Mountains. These aren't myths, they're molecular imprints. They arrived not as settlers, but as shadows riding sweeping armies. Assyrians, Persians, even Macedonian phalanxes under Alexander the Great, between 2,200 and 3,750 years ago. That means some of your distant ancestors might have descended from the same lineage as modern-day slaves, Iranians, Afghans, even parts of South Asia. It's an intangible inheritance, one without monuments or ceremonies, but more real because it's biological. There are no folk songs here, no spoken legacy, just silent footprints in your genome. And yet, that ancient ebb of movement intersects with everything we've uncovered so far. Crusader Y markers, Neolithic migrations, maternal echoes, religious gates. It means the European thread in Lebanese DNA isn't one story. It's a tapestry, woven from Canaanite roots, steep winds, and crusading shadows. This step connection expands the horizon, but it also deepens the mystery. Because if 7% of your DNA came from an ancient, unremembered wave of Eurasian conquest, how many other hidden migrations lie buried in your cells, waiting to be rediscovered? Which raises a final question. How many hidden histories still live within a single Lebanese genome? Lebanese DNA is not a single thread. It's a tapestry, woven in fire, faith, and migration. Your genome isn't a sentence. It's a library, a story stitched through 3,700 years of continuity, upheaval, devotion, and survival. At its root lies the Canaanite foundation, identified in the 2017 Sidon study, where 93% of Lebanese autosomal DNA still echoes the Bronze Age. But layered atop that core are genetic brushstrokes from across continents. The R1b marker, brought by Crusaders between the 11th and 13th centuries, still lingers among Lebanese Christians, a medieval whisper of Europe. The J2 lineage, far older, traces back to Neolithic farmers of the Fertile Crescent, who once crossed from the Levant into Europe with seeds and language. Further beneath the surface lies a 7% imprint from the steppe, nomadic ancestry from Eastern Europe and Central Asia, carried by the Persians, Assyrians and Macedonians into this land of cedar and stone. And then there's the maternal thread, mtDNA, revealing hints of maritime Europe through Phoenician trade networks, where Carthage, Cadiz and Sidon once shed blood through saltwater routes. But genetics is not a mirror, it's a trail map, and religion, over centuries, carved its own paths through this landscape. Faith didn't just divide, it fossilized migrations into fixed bloodlines, turning family trees into cultural fortresses. What survived wasn't the conqueror's name, it was the genetic code that refused to vanish. So if you stand today in Beirut or Tripoli or Tyre, your identity isn't just who you come from, it's who made it through. Next episode, a forgotten Phoenician genome found not in Lebanon, but in a Tunisian tomb.